This conference will now be recorded.
Okay, so okay, so let us just start. What is exactly business forecasting? Because the session is we are going to be discuss how we can predict, how we can forecast uh, business related things. So virtually every business decision and process is based on a forecast. A company uses its past sales data to forecast what is same value as what its sales value will be for next 12 months. The forecast help the company to allocate what resources such as employee might be required in the demand. So basically this term is basically called demand forecasting. Some maybe the demand can be anything. Maybe demand can be the in the term of employee, demand can be in the term of the product, demand can be in the term of the any item corresponding any store, because company having multiple store and multiple item. So how you can forecast what should be the demand, what should be the demand at a specific time, or after 2 months, after 3 months, after 1 week, what would be the demand of any goods, any product, any item, anything. So here we can play with the forecasting. So we are going to work with the very good algorithm. Yesterday we worked with basic things like what is the time series data, how we are not how this is not normal linear regression is not applicable on time series data, and how we can uh, apply the basic AR model, MR model, ARIMA model, S model, how we can apply all this model. And after that, how what should be the basic uh, uh, tendency uh, your time series data have, like trend, seasonality, and holiday effect. So these are the basic things. So now let us consider we have a one data set and we are going to be forecast something. Okay. So in business investing, if every data look like that, the prediction is going to be completely depend upon its linear trend, its seasonality in holiday. So business time series can be characterized by long-term linear trend, yearly seasonal effect, and holiday effect. So all this term yesterday we discussed very deeply, means how what is the effect of seasonality, how you can decompose time series data into their component. So we completed all these things. So now I'm going to much focus on uh, practical part, how we can do all these things. So as of now we are aware with the ARIMA, means auto regression, moving average, all these things we work separately and also we mix together. And we already seen that the model, the time series data may contain stationarity concept, and may contain non-stationary uh, concept. So the first thing we ARIMA model is only give a good response when your data is a non data is a stationary. So we already check how we already work with the AD Fuller test, already work check the its confidence and like p value, and decide this your time series data is a stationary or non-stationary. If the time series data was if the time series data is a stationary, non-stationary, we apply some mathematical algorithm, and that algorithm try to convert the non-stationary data into stationary data. Like we In ARIMA case, we integrate the thing, difference the thing, and then in normal case, we can take a log algorithm, logarithm of data, and then again check its seasonality, check it stationary and non-stationary. There is a lot of way we already discussed. Okay, so as this assumption, I'm going to be start another algorithm. The algorithm is very popular for demand forecasting and all, and for business analysis, for anomaly detection and all. The for okay, so the name of the this algorithm is known as a Propahat, and there is a one Propahat, that is a very first algorithm. There is a very first version of this algorithm, and that designed by Facebook. Okay, that is a Facebook data science team designed this Propahat algorithm, and really it's worked very correctly when the data having seasonality, trend, and holiday effect. And few years back, they launched their latest version, their updated version, and that version is also called known as a neural forecast. Okay, so let us understand what is exactly Propahat. Okay, so Propahat is a procedure for forecasting time series data based on adaptive model, where non-linear trends are fit with yearly, weekly, daily seasonality plus holiday effect. We already seen yesterday that prediction, your seasonality, your linearity, trend, your like randomness can be additive and can be multiplicative. We already seen. So here the Propahat focus on adaptive nature of all this trend, seasonality, and holiday. The Propahat work best with time series data that have a strong seasonal effect, and several uh, seasonal of uh, uh, server. There is a lot of historical data, we can say that. Okay, and what is the most important thing? If you work with if you already aware with the linear regression and auto regression model, they are not very good with outlier. They are not automatically handle the outlier, but Propahat is a robust to missing data, and and it all automatically shift toward trend and also handle the outlier. Okay, so what is the important thing? That is so if the data having seasonality, if data having trend, if data having holiday, that can be automatically adjusted by Propahat. Okay, Propahat is based upon all this like thing, and that is an adaptive model. I'm going to discuss what is exactly adaptive model. What is the if you think about limitation term, the Propahat is work for unilateral variable, means there would be one prediction, there will that can be work for unilateral, means one there the data should be n across 2. So first column should be time, and second column should be whatever you want to predict. So that's the thing. Let us start how what we discuss, what is a like these things, what is the basic things we need to know, and then how we can adjust. So okay, so then after I'm going to be start some take a simple examples and simple data, and I'm going to be we solve all this. After that the session will be complete practically. I'm going to write a lot of code and all. Okay, so what exactly the function yt? What is basically prediction function, and yt is and that is basically gt plus adaptive. I just say adaptive st and plus ht and plus that is error t. If you remember the ARIMA model, what was the ARIMA model? ARIMA model having a very specific a formula. What was the formula? What was the equation for prediction? Yt is something different. What was the yt? Yt is simply if you know about the ARIMA, what was the prediction? It is a constant. If you check about that is for Propahat. That is what it is for Propahat. and ProPahet is designed by Phase. If you let us compare with my ARIMA model. What was the ARIMA model? First you add some constant, that should be the some constant plus linear combination of, first linear combination of lag of y, and we can and that and it up to p. We decided about what is exactly p. Similarly, what was the second term? Linear combination of, we can say that a linear combination of error lag of forecast error, and that is up to q lag. So if you remember this thing, you can see the difference. The yt is based upon gt, st and error, and here the yt is a constant. There is always, you need to add some constant, so that is a biased and linear combination of lag of up to p and lag of up to forecasted error up to q. So you can see here there is a no seasonality controlled by YT. There is a no trend and all. You need to manage all these things. You need to convert the stationary data, non-stationary data into stationary data. What it mean? What it mean for converting non-stationary data into stationary? There is a statistical parameter like mean, median, mode will constant at some over the time. But these thing can, these we are not we are not doing such thing with the ProPahet. So we can say that ProPahet can work for non-stationary data also. It is automatically control, automatically adapt seasonality, holiday effect, and trend and all. But if you go with the basic ARIMA model, you need to handle this. We need to convert before train the model. Before start the ARIMA training the ARIMA model, we need to convert. We need to convert the ARIMA model, the non-stationary data into stationary data. Are you able to understand? And then why we also discussed PDQ model. Okay, so that is ARIMA is going to be used. P is going to be take how much RT regressive lag you are going to be take, what should be the how much lag you are going to be take, and then is a how, what should be the differentiation. And what is the purpose of differentiation? Differentiation is basically try to convert the non-stationary data into stationary data. Any problem? Any problem as of now? I think is it clear? So that is a basic. So what we can see in the term of ARIMA and the ProPahet. ProPahet is very good when your data have a seasonal effect, when your data have a trend and all. So that can be handled. So what I'm again try to repeat, like ProPahet is a procedure for univariate time series forecasting data based on adaptive model. Means whatever the forecasting you are going to be done, that can be univariate. Means there should be date and there should be your like, let us take, I'm considering about the cells, and in ProPahet case that date and cell is also predefined. There is a you need to convert data into ProPahet data format. We are going to see. So I'm again repeating, the ProPahet is a procedure for univariate. Univariate means one variable time series forecasting data based on adaptive model, and the implementation support trend, seasonality and holiday. It works based with a time series that have strong seasonal effect and historical information. Okay, and what is the most important thing? That is a automatic handle missing data. Okay, automatic shift trend. If the data is missing, then the trend is going to be automatically shift, and most important that handle outlier very well. So now I think you are able to compare what is basic difference between these two. So what is exactly, if you see here in GT, what is the meaning of GT? GT is a trend. GT is a trend function. Let go and repeat the equation again, so you people must clear. So what is exactly YT? YT is the like given by the additive of GT is a nothing. GT is a, we can say, the trend. If you see the ST is a nothing, is a seasonal effect. And if you go with the HT is a holiday effect plus some F. So what is exactly GT? GT is a trend. We can say that is a trend. And what is exactly trend? Trend. So trend is a function which model which is going to be handle non-periodic changes. I think you people, I already discussed about the trend and all. It is a okay. It's a not, if the mean is constant over the time, so we can say that is a there is a no trend. If mean is increasing over the time, we can say that the data having trend. So GT is a trend function, which model non-periodic changes using either a non-linear saturation growth or piecewise linear regression model. Because suppose, let us take your mean is change, your mean is change, your mean means, let us, mean is here is this, and mean is here is this, and mean is here is this. In particular time interval, your moving mean is change, or mean is change over the time. Let us take M1, M2, this is M1, M2, and M3. So if mean will change over the time, so definitely they have trend. So how we can handle this trend? Either you can handle this trend with the non-linear saturation growth, or you can work in piecewise manner. You can control, we can work first this one, then go calculate for this one, and go and calculate it for this one. That is called the piecewise working. Okay, and then you can configure your parameter. And then what is exactly ST? ST is a seasonal function. It can be yearly, weekly, and daily. So automatically your PROPAHAT can handle yearly seasonality and weekly seasonality and daily seasonality. That is the most important. Your ARIMA model automatically change yearly, weekly, and daily seasonality. We are going to see all this thing very clearly. So what I emphasize again, I just emphasize on ST term. So ST is a seasonal function, GT is a trend function, ST is a holiday function. We can think like that. So ST is a seasonal function, and the seasonality can be yearly, weekly, and daily. So ST is a seasonal function which model the periodic changes. I think yesterday we see the trend is a non-periodic and ST is a periodic. Okay, so that can be automatically handled, and internally this is a handled by some mathematics, some Fourier transformation, and some. I'm not going to discuss much more about that. And what is the HT? HT represent the function for modeling holiday for a special impact event, and even that can be customizable. Maybe in US holidays holiday day are different, and in India holiday they are different. And if you in India, in UP there is some different holiday, and in Maharashtra, Kerala there is some different. So we can handle the holiday, we can customize holiday, we can give that particular holiday, and we can train the model with given holiday. Okay, depend upon local holiday and global holiday and national holiday and our international holiday. And what is exactly error? I think everyone understands the error. Generally the error we consider, we assume it should be like Gaussian distributed, it should be the normal distribution, or we can say that is a randomness. So now everyone, this is clear what is exactly PROPAHAT, and okay, and what is the advantage of PROPAHAT with compared to the ARIMA. ARIMA is basically a very simple model. When your data is not don't have a much linearity, much non-linearity, then we can directly go and choose the ARIMA and forecast. But if data having huge number of data having a lot of seasonality, a lot of trend, a lot of holiday impact, so better if we can go for Propahat and Facebook, that is the product of Facebook, and the latest version and the updated version of Propahat is also in the market, and that is known as a neural Propahat. Okay, if any question, just ping me, then I'm going to be continue for practical point of view. So meanwhile, I'm just open my Anaconda. This is Anaconda. Let us see it is running or not. Okay, so this is so just come here into my here. Let us search this word. I'm going to be write code here. So okay. So I'm going to be check how we can use Propahat and all. Yeah, let us check self prediction. You can use forecasting, whatever the thing. Generally, Trump generally forecasting. So that's the thing. Okay. So if any doubt as of now, please buzz me. I'll try to teach you. So if you people are aware with the sklearn or machine learning sklearn framework, so that is a quite similar. Okay. So first of all, I'm going to search for data. For data, I'm going to be for good source of data is a Kaggle itself. From Kaggle, you can download a lot of data. And let us take. I search on Kaggle. I go to the Kaggle and I tried. These are the data source. Kaggle. Let us take sales forecasting data. So if you see the lot of sales forecasting data is you can easily find. Let us take store sales prediction, Walmart recruitment channel. So I just store the sale forecasting data. This is the data. This is a problem. Even this is a part of hackathon. You can go and submit your forecasting result, and maybe you can win a lot of prize. Okay. So and all the detail is given, like what are the goal of the competition, how you can submit all these things, what are the exactly data and all. So you go here and download this data. Go here, there is a lot of data is there. So mainly the data having 10 train data and test data. So train data is basically for training your model, and test data is basically you need to check your after prediction, after creating a model, you need to check what is the response of your model. So for your better understanding, just go and explore the data and try to check it. But let us, I downloaded this data. Now I am just going to work with the only train.csv because the data is a 128 121 dot means near about 120 MB. So maybe in that situation Panda cannot be handle all this data because the train data contain almost 10 lakh sample. So if you want to plot the 10 lakh sample, maybe your Pandas is not able to handle due to the memory problem. Okay, so that's why people go with some GPU then GPU requirement come into the picture. And what is the better? Go to the online, because maybe my system is not my system configuration, maybe there has some limitation. So better for learning purpose, you can go to the over the cloud. You can use the Colab. You can also use you can also use SageMaker and all. So let us first thing first. Let us I think the data is let us first I load this data and then we can start it. So you can go and download, and all the information is given here. The what is exactly like a thing and all. Similarly, there is another data predict future sale and also. Yeah, you can go and take the data after this session. I will going to share my notebook and all everything. So please be focused. I'm not going to be I'm going to be write whole code. So one by one use focus. And as of now, we just code very like roughly way. And so so today I try to create the code very structurized and try to create a function, so you can utilize the function, you can copy paste the function, and not only for this particular problem, you can apply that particular problem with any other problem. So what I'll try to do, I'm also going to try to create a one package of my own function. So that package you just share with anyone and they can use it. Okay. So let us okay. So first of all, I'm going to be discuss about what is exactly data. So for importing the data, we required what? For importing the data, we required a library that is called import pandas as PD. Okay. Similarly, I required some mathematical computation. So for mathematical computation, I import npisa.np. Similarly, for some visualization purpose, I'm going to be import from matplotlib, import pyplot as plt. So there are other visualization tool is there, import Seaborn. You can use Seaborn as SB. May or may not, I'm going to use Seaborn in that particular case, but yeah, I'll try to uh, uh, give idea what are the library available and what are the library you must aware if you start working. Okay, sorry. So whatever the library, if you want, must means we can say the generic library. Okay, after that I just import all this thing, and similarly I'm going to be import propat. So propat, for propat I simply import from propat. You need to install propat. Okay, that is it. Okay, so simply pip install propat. I import from propat, I just import propat. So that is a simple and very. So now I just imported all the necessary libraries. So let us take, I'm going to be import my data. Let us take pd dot read, same data I'm going to be read CSV. Okay, you can directly copy and paste the data from Kaggle directly with the help of link. So I'm not going to be just do this. I downloaded this data, and the data I'm going to be utilized, and the data is stored in my local repository, local system. So that is my data. That is a lot of data I already have. So I just copy this place where my data is saved, and the name of data is basically uh, store cell dot csv, and I put, well, first of all let us read this data. Maybe if maybe my data name may be wrong, so let us check what is the name of data again. So that is, go to the store. Yeah, that is a store data, sorry. The name of data is basically store data. The name of data is basically uh, store data. Okay, so that is not a store cell, that is a store data. Okay, so I run this. Now I can see this data. If I check the data, I can find this data. And if you see this data, the data having near about 9 lakh samples, huge amount of data. Okay, and now let us discuss about something about data. Let us take a dot head. I want to make things simple. Let us take I just two. So the data having date, store, item, and sales. There is a 4 column you can see. First column is a date, second column is a store, and third column is a item, and fourth column is a sales. So let us check how many store, how many different store is in complete data set. So I put my data, I put the store, I can check dot unique. So you can say I having 10 store, 10 unique value, 1 2 3 4 5 6 7 8 9 10. In complete data set I have a 10 different store. Let us check how many item is there, how many different item is there. So I just go and check this item and I put here. So I have 50 different item and 10 different stores. So every store may or may not have 40 different items. So how you can start prediction? We are going to be start predicting item, specific item with specific store. Let us take, I want to forecast the total number of item after 1 week at store 1. My question, my problem statement is clear, that you are not going to be apply the prediction on complete data set. You need to, first of all, you need to decide the target. Oh, I want to do some prediction on that particular store, and that particular store I want to do forecasting, demand forecasting, maybe for item 1, item 2, item 3. So you need to create a model. That model is a much adapter to take the store number and item. So if you give the model to store an item, data is going to be filtered and automatically it's going to be done with that particular item and that particular store. So question is, this is clear, everyone? Is it fine for all? So the data set having used a sample near about 9 lakh samples, 9,30,000 sample, and the data contain time series information from 2013 to 2017. That is the date, okay, and okay, daily basis data I have with corresponding to every store and the item. Let us consider consider a little bit about the Flipkart. So I just consider a Flipkart maintaining their data, all items. So how the Flipkart is going to be maintained? Maybe the Flipkart have 200 store, okay, and every 200 store they have 50 different items, and maybe demand of the any particular item at any particular store is higher compared to the other store. Maybe if you talk about some places, maybe in Flipkart, in UP, and very specific in UP, there is a one store in Varanasi. So maybe in Varanasi, the item, the forecast demand of the item at any specific store is different, and in Delhi different. That is a completely a change. So we are not going to be applying, we are not going to be all the data to the model to forecast. Okay, it may be misleading, the result would misleading. So what we are going to be do, we are going to be design a method. That method going to be takes some going to be take some input from you, and then automatic production is going to automatic prediction is going to be happen. Let us take, I want to a Flipkart a project manager or forecast salespeople want to predict what was the uh, demand of item 8 at store 2. So he is going to be provide two arguments, item and store. So we can write a generic function. That function only extract the information at given specific store and item. Is it clear? Is it clear for you? So let us do how we can perform this thing, how we can do this thing. Okay, any problem as of now, please? Okay, so let us, I'm going to be create with a function. How we are going to be, I'm going to be create a function. The function is going to be called def. Okay, so I'm going to create a data. Name of the function is the data cells. Let us take item and a store. So with this function, we can extract the information, item specific information and store information, store specific information. It will take a two argument. First, what is the complete data? We can say that the master data. The master data, we have a data. We can say here master data. Yeah, complete data. It's completely up to you. What? Okay. Here I'm going to put complete data. Complete data, and then I'm going to be give item first argument and store second out. Okay. Okay. And that I'm start writing the code. So here I'm just take a variable item, store and item and store. So that variable going to be handle the item and cell data. Okay, store data. How we can extract? So I'm going to be this complete data. That is a complete data. In that particular complete data, I need to access. I need to access complete data. And what exactly I want? I want in the data you have a store. You can say that I'm going to be compared with the first of all item. Okay, I'm going to be just compare item, and item is provided by you, so that is the item. Okay, item is provided by you, and I just going to be write a logical operator. So in complete data, I'm going to be extract the data when item equal to item, and that equal to item is given by you. And again, I'm going to be compare with another functionality, that is AND operator, and that particular and after again I'm going to use complete data, and I'm going to be compare with store, and I'm going to be just compare whatever the store given by you. Okay, and then I just close this function. Okay, and after that I'm going to return this store item data. Try to understand. I return one basic function. I return a basic function. What is sales data? I put this one. Okay, what I mistaken I made. I just forget to open this. Okay. Let us take I complete data. I compare with item, and that should be also here. Sorry, and it should not be like here. Okay. So you can see here now I call this data. Let us take data cells store item. I'm going to be pass master. What is the name of master data? The complete data is in data part. And what is exactly item? I want to extract all information item 1 and store 2. Let us see. So you can see here I can extract the information, all this information only related to the store 2 and item 1. So that function is going to be returned. Let us take no, I want all the information related to the item 2 at store 3. Is it clear? So it becomes complete dynamic. You can just utilize this thing. Okay. So I think the problem what I am going to be just the problem was complete data is that contain the all the store information, all the items information. So whatever the demand forecasting we are going to be apply, that the algorithm is going to be not going to be give the all the data, because that's very difficult. That is very like misleading, that that if you given all the information, how we are going to be calculate the very specific information. So instead of doing all this thing, we try to design one algorithm, one function. That function can much adaptable, that you can just extract any store information and any item information with respect to. So here is the dynamic is store and item. Now, so if you see here that information is 2129, so you can just do the reset index. a lot of things we can do. I'm not going to be do. So here I just put all this data. So now I just, okay, so I'm just comment. So any problem as of now? Now let us how we can plot this data. Suppose I want to plotting this data. For plotting purpose, I'm going to be use for plotting purpose I'm going to be use Plotly. Plotly is a very good visualization library. There is a lot of library available for visualization purpose. That is a Plotly is there, Altar is there. You can go for basic Matplotlly is there, Seaborn is there. So I'm going to use Plotly. So I import Plotly, and that is available for JavaScript, Python, even R programming language. And Prophet is also available for R programming as well as Python programming. Okay, so I just import Plotly dot graph object, and I just as graph object. Similarly, I'm going to be plot all this visualization uh, into my notebook, in Jupyter notebook, and there is also provision. You can run the code into a separate HTML file. You can integrate. You can run the code into the Google Cloud. So not Google Cloud, over the cloud. Okay, that given by the Plotly, that is called the chart, Chart Studio and all. So I'm not going to be discuss. So everything, the plot, whatever the plot I'm going to be design, so I'm going to be design in that particular notebook. For that purpose, I'm not going for online. So I'm not going to be for online. So I'm only going to be used for offline. So Plotly dot offline. I'm just working with the offline. If you see here, there is a two option is there. Offline is there. So I'm just applying the offline as py. Okay, and then I'm going to be enable my interactive Python notebook. So I'm going to initialize it py dot init, the notebook mode, and it's enabled. So now I can apply. So I just imported my Jupyter. I'm just means imported Plotly as a graph object. And okay, so let us plot this thing. How we can plot whatever the data. Check what is exactly data and all. So for plotting purpose, let us take. So let us create another function. I'm going to be take the function def, and I name this function is a plot. Whatever the plot data I'm going to plot, store cells, store item data. Let us I give data, store cells data. I'm going to plot. So for that purpose, you require the cells data. Okay, and you need to again define the store and item. Okay, so similarly you can copy paste the same command, because okay, here, okay, I just copy paste the same command here. Now after that I'm going to be plot. For plotting purpose, you need to go the figure. I just initiate on variable, the name of variable is a figure, and go, it's the object of graph, and graph is basically a function available in Plotly. And so I just call my figure function, and I'm going to be plot my line time series plot. So for go dot, the plot is basically called the scatter plot. So I plot the scatter. Now I'm going to be give whatever the information on the x-axis. I'm going to put the x-axis what, item cell data. Okay, and I'm going to be create on x-axis, it should be the date versus cell I'm going to predict. And y-axis what I want to put, anyone? Y-axis I put the item data, item sales data, and it should be sales. Okay, you can see here. Okay, now again, if you want to put the what is a basically x label, y label, so graphical labeling of your data, so I just put the update figure dot update you can see here, and there is a layout. So a plate layout. So I am going to be use some customization. Let us take. I will throw what is the what function I'm going to be write in the example. There is a lot of function for here. I'm just going to be closest. I will show when run when output with the help of output. Title text, that is basically title. Whatever the title text you want to title text. Title text is basically what? Sales versus item. Sales versus we can say that, yeah, store versus item. That is basically because we are working with a store and item. Okay. And x-axis, what you want to put? I put the x-axis. X-axis. X-axis title. I put x-axis title is the date. Similarly, you can put y. We can put y axis title equal to sales. Okay, and then everything is done. I'm going to be show figure dot show. So that function I have written. Now I'm going to be call this function for visualization purpose. So I'm going to be plot this store data. What is exactly master data? Master data is a data, and which store you want to check the pattern. I'm going to put the store one, and what is the type item? I want to see the item. Let us see. What is error? Complete data is not defined. Okay. So basically, this should be completed. Okay. So not callable. Okay. So maybe I missed something in the while writing the code. So I put the go dot figure. I apply go dot scatter. I put x, and in the x item is store data. I put the date, that is fine. Y equal to item is store data. It is also fine. I did it. Fine. Now it's fine. Anyone can tell. Okay. What is the problem? Go. The error is basically in that particular line, and that particular line is here. Maybe I misplaced any spelling. That is a cells basically. Okay. So I date and cells. Okay, no problem. Let me check again. Again, right. Uh, I just take a figure, go figure. I take a go dot scatter. I put x equal to item store data, then date. Y equal to item sales data, then sales. Close this thing. Fine. There should be no error. Figure go dot figure. Object is not callable. Let us clear this whole the thing and restart and return all. Maybe okay. That's happened because I try to just create all this thing very dynamic. Don't worry. So what I try to do, so I write the function, then you can apply this function. Let me just comment this 3 line and check if anything mistaken, then I just apply again. Okay, so that's fine. Okay, that's run. Now I'm just go with the again. I just take a create a figure object. Let us stay again, right? Fig figure object, I just call my go object, graphical object, then I call my figure, capital figure, call my capital figure, fine. And after capital figure, I just call a list. In that particular list, I'm going to be plot go dot scatter plot, go dot, sorry, it should be capital, maybe mistaken. Dude, oh yeah, that mistaken I find. That is a basically capital S. Let me check again. Okay. What is the mistaken? Yeah, there is a closest. Maybe I miss spelling. Yeah, fine. Don't worry, don't remember anything. So now you can see this. This is a pattern of store data cell. So what we need to do, you did anything. If you want to see the pattern, I want to see the pattern at store 2, you need to remember the first argument is a store, then second item is a item. Okay. So okay. So if you want to much confused, you want to focus. So I put the first is a item and second is a store. Don't worry. Okay. So that is a like trend of store 1 at item for item 2. Similarly, if I run at store 2 and item 2, you can see that is a pattern. So you can see what is the purpose of this thing. Okay, so it having started from January 2013 to July 2017. So any question as of now? Any question as of now? You people are trying to understand what I try to say, try to create. So I created some general. Don't worry, just see all this thing. I will share the code, complete code. I put the complete code into the GitHub repository. Why I just try like that? After that, I will try to create a separate package, and I put all this package into that particular function, and you can call again and again. Like if you like, you can call now import as a you import the sklearn, import the numpy, import the panda. So I'm going to be create a one function. That function should be known as a cell forecasting, and you can import the cell forecasting and you can utilize with any program. Okay. As of now, any problem? So what I did, I created two function. Let us take, I named the function also for your purpose. I put here heading. Please, I put heading. I put here extracting data store versus store and item. So here the store and item is a dynamic. So here I'm going to put at which store information you want. Similarly, I'm going to be, this function is, what is the purpose of this function? Plotting. Here I'm going to be plotting store store and item specific cells versus a date. You can say as a date versus cell and cells versus date. Don't worry, it's completely up to. So that is the thing. That is the two function I created. Now if you see here, here I put the date, here I put the cell. Now you can see here, you can find everything very clearly. At that particular date, you can find July 2015. The item was the sales was 19. You can see here. And similarly here, if you put in that closest, you can put the X, and that is called the uni field. Maybe I wrongly spelled, so don't worry, I just call this one X unified and Y. So that animation, that then everything will going to be changed. If I put this, you can see here, now you can see here, it is going to be changed like x axis. You can see like that. So that is a one important thing about the visualization and all. So it's completely it's complete upon you which one you're going to choose. So similarly, if you put the y, what is going to be happen? It is going to be like y axis, okay, like that. So that is completely up to you, okay. You can see. So it is in my opinion, I'm going to use previous one, and that was closest. Okay, so the closest is that which, okay, fine, that is the thing. Anyone, as of now, anyone having any problem? So with this function, we can create all this thing. We can create all this thing very like dynamically. Okay, so the title is basically store versus item, the x-axis. So you can simply put okay, no, I want to the predict, I want to check what is the store information at store 3 and item 2. So that is completely generic. So that is a complete thing, complete like information about all this thing. So now I need your quick confirmation so I can move for forecasting part. Anyone having any doubt? Sanjana, Dheeraj. As of now, everything is clear. So, so initially I just created. Yeah, thank you, Dheeraj, for confirmation. Thank you. So, and I think it's interesting. Yes, sir. The graphs are really interesting. So that is the advantage of, that is the one goodness of this Plotly library. If you go with the Matplotlib and Seaborn, you need to write a lot of code. And another important thing, directly that would be integratable with website and also. Okay, JS support. Okay, and okay, fine. So let us move. So now I have the data. I written some function. That function can easily extract the store and item specific data. There is no worry. Okay, now I'm going to be work. Let us check. I have a data. The data is basically that particular store 3, and I'm talking about the item 2. So I want to predict. I want to demand forecast. I want to predict after 2 months what should be the demand of item 2 at store 3 and store 4. Are you getting that type of decision, that type of business decision now we can take? So now forecasting come into the picture. So for forecasting purpose, you can see that particular data. They in that particular data you can see the trend is there. Okay, seasonality is there, lot of fluctuation is there. So that type of data, that type of time series data, that cannot be handled by ARIMA. If you want to handle with ARIMA, you need to do a lot of things. Okay, so now I'm going to be use Propahat, and with the help of Propahat, I'm going to be create a forecasting model. Okay, so that is a one important thing you need to remember. In the Propahat, there is some specific column name for date, and there is some specific name for variable. Okay, that is a fixed, all fixed, that Propahat give. If you want to give with a date column, that column should be the date, mentioned as the date. That should not mention as the date or any variable. It should be mentioned as the DS. Okay, DS means date set. Okay, and the column, prediction column, should be Y. Let us make a much clear. As of now, we have a data. The data having two things. I'm going to predict the sales and sales. So that here it's given as the date column, and here is given as the sales column. Okay, so whatever the there is a one predefined identifier we need to give. If you means this date is not going to be understood by Propahat, and sales is not going to be understood by Propahat. You need to just replace date with DS and sales with Y. That is a uniform for all. So you need to what exactly I want to just discussed that if you want to give your data to the Propahet model, then data should be in the form of Propahet. What is the Propahet format? That date should be the replaced by ds, and target or cells should be replaced by a y. So let us take I'm going to be create a one function. That function is going to be convert data into Propahet format. Propahet format. What is exactly Propahet format means? Means date should be replaced with ds, and any prediction, let us in the case our case cells be replaced with the y. That is the thing we need to do. That we think we need to convert. Okay, so that is a, if I spelled anything wrongly, so just apologize for that. So now I'm going to be create this thing. So I have written one data def, and I call this function is a Propahet data format. So I need to convert the Propahet data format. So for Propahet data format, I'm going to be call the data. We can say the item cell data. Why item cell data? I'm focus on. Let us take here item cell data. That is variable. You can choose any variable. For my purpose, I'm for my semester. So you people understand what is actually data item store data. Item store data is a data with any specific store and in any specific item. Then I'm return the code. Let us call the data cells. Now it having date and cells information only. So how you can extract the date and cell information? I call this item and put this item here, and I only extract that because the forecasting is going to be happen for date and cells. Try to understand why date and cells, because the item store data having all store same store and same item, because we are going to be extract the information for specific store and specific cells. So now we have focus on only date and cells, and then I need to convert this date and cell into, you need to change the column. Let us take I return this thing. Let us take I return. First of all, let us take I return date cell. Let us see what is going to be happen. I call this function and I put data format. What it return? Store function is not defined because I need to call this function. Okay, sorry, I need to call this function for storing the data. So let us call this extract. First we need to extract the information. So for extract the information, okay, and I save this information is item sales data. Try to understand what I try to do. Okay, and here I put the complete data. I'm talking about item 1 and store 2. Okay, so it's completely up to you. I'm talking about and if you want to try to synchronize, I'm talking about item 1 and store 2. Okay, so if you run this code, complete data is not anything, that is a data. So if you run this, and if I try to print store data, you can see here date and store is common because I'm talking about second store, and item is unique. So that store and item is same, means item having only 1 and store having only 2. So why? So here I need to fit only date and store. The prediction is going to be happen with date and cells, because I already my data is a very specific in the term of store and in the term of item. Okay, so for that purpose, if you run this code and you can see here what is going to be happen, I can find date and cells only. I just remove remaining one. Now I'm going to be convert this date is ds and cells is y, because that is a mandatory if you want to work with a Propahet, because there is a standard of Propahet. You need to convert the date column with DS and sales column with Y. So let us take how we can do. So I'm going to change my column to a very basic way. State data date dot sales. I'm going to put the column. I want to change the column. So let us take C columns, and I'm going to be simple put DS and Y. First that is a DS and second is a Y. Now you can see this date and sale. Now you can see what is the problem. Date sales column Y is not defined. Okay, sorry, it's my bad. Okay, it should be double inverted comma. Oh, sorry, it should be as a string. Now you can see here, now your date is replaced. No, what is happened? It should be replaced. Panda does not allow the column to create via this. So what I did, a data sales I created. Oh, I misspell the column name. CLUMNS. Okay, now you can see here your initially DS was date, so date is replaced with DS and sales is replaced with Y. So that is a specific format. Now let us save this variable into prophet format. Let us call is prophet data format. Now, so I have a now prophet data format. That prophet data format is basically that data is only for store 2 and item 1. So if you want to change a store and item, you can change it and rerun. Everything is going to be updated. Now tell me, is as of now everything is fine? As of now everything is your control. So okay, so what I did, I start from very basics. I take a problem, the problem having sales data, and sales data is corresponding to the lot of store and lot of item. The total number of store is a 10, total number of different item is a 50. So I need to forecast the store specific item, store specific item. That is the, we can say that you can frame in different way, it's completely up to you. But I try to find if your project manager or your sales store person or anyone or inventory people come into you and ask you, can you tell me what should be the total number of item required at store 2 next week. So you can tell them easily with that particular model. And maybe another one ask you, can you tell me what should be the item at this item 2 and 3 item required after 2 months at that particular store. So you can create so for that purpose we created already functions, and you just give the information to the function. That function do rest of things. Now, so as of now we did all these basic things. I created a function. That function is going to be convert my data into data frame into prophet data format. Now come into the forecasting part. Let us a 5-minute break, then we'll start again.
This conference will now be recorded.
Okay, so now coming to the forecasting part. Okay, so here I'm going to be define the model. I'm going to be called the prophet FB model. Name is PFB model, and I name is a model 0. I'm going to be design a multiple model 0, and then everything I just encapsulate into a function, and then we start using function. Okay, I call the prophet, and that is a by default. Prophet is by default. I'm not going to be take any argument. I'm not considering what is happened with the change point, what is happened with like seasonality and all. I just take whatever the default behavior I'm consider. Then after I try to assign some seasonality, some weekly, daily, monthly, whatever the thing I am going to be assigned. So I just simply create a one call functions very similar to sklearn. Okay, I call my function. The name of function is a propahet. Okay, and what is a propahet? It is a very uh, it's going to be handle the time series data forecasting and all. Similarly, I'm going to be fit my data. Okay, so that is a model. Then I'm going to be call my PF model, and the PF model I'm going to be give fit very similar to the sklearn. And here I'm going to be give this propahet data. What is exactly propahet data? That propahet data is a for that propahet data having information about store and item specific. Which store and which item is specific? I'm talking about store item 1 and at store 2. So that the information I have. So okay, I just create this thing. If you run this thing, your propahet model is going to be just to give one warning that you haven't enabled the seasonality. The seasonality is disabled. So you can go and just enable the seasonality. So leave it. We will taking care of this with the help of function and all. Okay, after that, if you see here, so I have a data. The data now my model having forecasted. We have a model having a model have trained with propahet data. So that model, that propahet having all the information about sales versus date uh, at at store 2 and for item 1. Now for prediction, let us forecast. How we can forecast it? Let us take what is we need to generate a future data. We need to generate the future data, and after generating the future data, then we will check what is how our model is how model is working fine, model is not working fine, and then we will take a decision. We will take the what is the error, what is the mean, what is the deviation, everything we are going to be considered. So let us take I'm generate a future data. Future data, and there is a function. The future data is going to be generated by this one, because what is now model having data, then we are going to be generate the future data. Future data means forecasting. We are going to be forecast. How we can make a forecast? So make future. I'm going to be create a make a future data frame. Now you can define period. How I want to period is 5, means I take a 5, and after period, what is the frequency? I take a frequency equal to, let us take. So at what exactly I want to predict the next or future 5 days data. If you put monthly, we are going to be predict monthly 5 month advanced data. So with the help of this, we have a model. We just with the help of this model, I'm going to be generate the data the next few days, next 5 days. Okay, and here I am going to be take in history. Means historical information I'm going to be consider. Okay, Is it fine? Am I audible to all? My screen is visible to all? Dheeraj?
Yes, sir.
Okay, so fine. Okay, so fine. So let us, I just generated the future data. Okay, now you can see the future data, and if you print this future data, you can see them. We have generated the future data like 1 113, 2 113, 3 113 and all, and that data is only for next few days. Next few means if you see the data, we have only 2017 data, but now we already generated some 2018 data. Okay, for next few days data. Now I just take this data, and now I'm going to be take the prediction forecasting with that particular data. I'm not generated the data, I generated the date only. Like if you want to generate, I want to suppose you have a data till last week. So if you want to generate next you want to predict some information for next week, so you need to generate the data. Let us take today is a 5th of March 2022, and you want to predict the 6th March 2020, 7th March 2020. You need to generate some date for date. So now I generated the next 5 date, and now we have a data. We have a date. Now I'm going to be asked to my model that can you tell me what should be the predicted value. Okay, so for that particular purpose, I'm going to be forecast. I'm going to be forecast. Forecast is going to be happen with the model you already trained. So model 0, and similar to the sklearn, very similar to the sklearn, very similar to the sklearn. Model dot predict, and I'm going to be give the future data what you created. If you see this information, you can see there it is going to be happen. The forecasting is happening, and now forecasting is done. Now if you see the forecast information, let us see what is it is going to be show a lot of detail. Now this data having your data, this data having your data frame. Okay, this data having your data frame, and that having, okay, all this information. What exactly trained what 22. I try to understand what is the why that means predicted value. So prediction is always going to be in three manner. What is exactly upper prediction, what is a lower prediction, and what is the actual prediction. So what is the additive term, what is these lot of term is what is a weekly lower, everything is going to be predicted. It's very clear information is predicted. So I'm not focused on much about all this thing. Let us create some meaningful information. So I convert the data frame. Okay, and I only from the forecast information I just extract some useful information. I extracted the ds is a actual date. Okay, and after that I want to also check what is exactly trend. What is exactly trend? I think you people have idea what is the trend. Then y, again I just take yhat means what is exactly like if you see the forecasted column, let us show you thing. If you see the forecasted column dot keys, you can see there is a lot of information. In that particular column, you have a ds, you have a trend, you have a y, like predicted lower, y predicted upper, trend lower, trend upper, adaptive term lower, adaptive term upper, weekly lower, lot of information. And that y at is a actual prediction. So I just try to extract. So let us also find what is the lower trend. So I just extract what is a lower trend. Where is a lower trend? Trend lower. Because some information is not very meaningful for us. So again, trend lower I calculated. I extracted. Trend upper I tried to focus, because I'm going to be visualize. So I just take ds trend y actual predicted value, yeah, forecasted value. I just take trend lower, and let us take y hat also lower. Trend lower, y take also lower in the proper way. Then trend upper and also let us take a y hat upper. So I have all this information extracted for my analysis purpose. There is a 2 comma mistaken. If you check the forecast value, now you can see the forecasted values test. I am not focused on all this variable, but yes, as of now I just focus some of So now if you see that I have a data, so this is my data, this is the actual value, this is a predicted value, this is a lower trend, this is a upper trend, and all the information is there. So because every time when you are trying to predict, suppose you are trying to forecast, so now the forecasting is not going to be done actually. Like someone asks you, can you tell me what should be the traffic on my website tomorrow? So maybe you are going to predict, maybe it minimum 100, maximum will be 200, and maybe in our, we can say in around 100 to 200. Okay, so that is the basically range. Actual is on the basis of data, actual prediction is going to be 20. You see here trend was 22, but your model saying no, it is a 12, it is a 12. So here prediction is very wrongly, it's very deviated. So that can be also handled with the seasonality, because I haven't taken care about the seasonality and all. So lower trend is 22, upper trend is this, everything is a mention, everything is a very clearly mentioned with that particular information. That particular information is very important for creating the important factor, for taking a decision, for generalize and deciding the anomaly, because anomaly is going to be decide on the basis of some statistical. So if something below this, that is an anomaly. If something above this, that is an anomaly. Okay, so in that particular case, the thing is going to be very helpful. Okay, so now let us there is already some plot function. Let us plot all this thing. So let us plot this thing very okay. So I'm just go to the my model. My model name is, let us comment this, and I think you people understand. So my model name is PF model 0, and dot, I'm going to be simply plot something. So plot, after plotting, and for plotting I'm going to plot my forecast value. Okay, I'm going to forecast value. If you see this thing, let us take, so you can see that this is a complete information, that is a complete. So you can see here that that particular color, you can the dark blue color is predicted something, and you can the dot, this is, we can see that is an outlier, these this term are outlier. So that is a thing. And if you see the lower light color and upper light color, these are the upper layer and higher layer. Okay, so this is basically the thing, this is the basically thing is done by this propahat, and automatically everything is calculated. That is a problem with my notebook, there is going to be replicate same thing twice, don't worry. So now again I commented. Okay, so let us go and find the change point, because at which point and at what is exactly date, what are the exactly a time when sudden change is going to be happen, what is exactly when the your trend is going to be changed, when in the up direction or lower direction. So that I'm going to be descend what is exactly change point. Okay, So I'm going to be create for change point. I'm again going to be call the different model. I'm just going to be for your purpose only. I'm just going to be call copy this thing, and I just put here. Let us take this thing much clear. Okay, so I'm going to discuss about the change point. So instead of model, I'm going to be initialize with first model, and there is a first model. Okay, so now I fit with the prepared data format, no problem, and I always directly I'm going to predict. Okay, for prediction, I'm going to be give a future data predict with the forecast data frame. So what is the forecasted data frame? That is a forecasted data frame. Okay, so I'm going to be give the forecasted data frame. Okay, and then I'm going to be plot the same thing with model 1. I'm going to plot the same thing with model 1, and then uh, okay, then I'm in forecast, and then I'm going to be add the change point with model 1. Add change point, add CHANGE change points to plot. Okay, and then with the figure, whatever the figure you are going to be receive, GCA get current access, and model name you have, this is a model. Okay, and then what is the forecasted value? That is a forecasted value. If you see this, you can plot this, you can see this change point easily. Add underscore, you may be okay, sorry, what I we need to add that change point now function. You have to import, so from Propahet, from Propahet dot plot, I just import add change point. Fine, now I just run this. You can see here fig is not defined. Okay, okay, sorry, I made one mistake. You need to convert design the figure now, so you need to save this figure into figure. Okay, now you can run it. Don't worry, don't remember the syntax and all. When error come, you try to solve that particular error. Don't worry, I haven't remembered all this syntax and all, but yeah. So you can see here, you can find the change point. How many change point you can see? 1 point, 2 point, 3 point, 4 point. And by default, what is the problem, or we can say that what is a like done, what is automatically done in the Propahet. Propahet is only going to be just detect the change point with some specification. If you know about the L1 regularization, that's all this thing. So by default, it's going to be just work on 25 potential change point, and on the only 80% of time series. So if you want to define some change point, you can also define the change point according to you. Okay, we will discuss how we can define all this thing. Okay, and when we create the model. Now after that, let us take, we have a change point also. Now let us check all the trained seasonality and what we have discussed. So what I mentioned earlier, that Propet is a very excellent though for those time series data, they which have seasonality and trained and all. So let us decompose the data. Let us decompose the all this data. So I just call my model one plot. I call my model one plot and just add this and just do the plot, and I component and I do the forecast. Okay, and then you can see this, the decomposition of data. So that is a trend. So you can easily see we have a increasing and cyclic decreasing trend in the data. We have a initially start the on generally a Monday, on Sunday the sales was very high, Monday is slightly decreased, then again Tuesday increase, Wednesday decrease, and after again Wednesday, Thursday, Friday and Saturday there is a increasing trend, seasonality. So generally people the item whatever the item is selected, are either one either two, item one at store 2 have much demand on Sunday, and Monday is the least demand, and Tuesday is again increase, Wednesday decrease, and after Wednesday it is a increasing up to Sunday. So that is a weekly seasonality. Okay, and if you check the yearly seasonality, so if you see the yearly seasonality, that is the yearly seasonality data. In July it was maximum, September is decreases, October decreases, November again December, January again decrease. If you say the January is also peak, lower, and again in the next January is also lower. So this is a again thing. So again thing is replicated twice. Any question? So you can easily see all these things. So maybe the whatever the data we trained, that is the overfit and underfit. Let us understand how you can control overfit and underfit. So we may overfit the trend change too much, or underfit that not enough flexibility. So that can be also handled with the change point scale, because what I mentioned, there is some default assumption that a change point is going to be considered for 80% data and some 25 point. So let us how we can control this overfitting and underfitting too, and with seasonality, weekly seasonality and daily seasonality, how we can control all this. As of now we haven't control focus on the seasonality and all. Let us check this. So as we see, there is a seasonality, there is a weekly seasonality in the data, so you can take a decision. Yeah, so what type of seasonality we required? We have a weekly seasonality in the data, even yearly seasonality is also data. So in our data there is two type of seasonalities, we can see weekly and yearly seasonality, and also there is a positive trend in the data. So that assumption, that business decision we can take with that this exercise. Now let us improvise a bit more. Anyone having any doubt?
Sir, how to know like the predicted forecast you have shown, no, sir, the weekly graphs, how accurate are they?
Oh no, accuracy I'm not talking. Accuracy, again, I just because if you talk about accuracy, we going to be calculate as if you remember, yes, yesterday class, the error was the accuracy or correctness was going to be decide on the basis of error that we calculated BIC. Have you remember?
Yes, sir.
Similarly, we are also going to be calculate the error in that case also. So our goal is that let us take you given you are a project manager, you are a store manager, okay, and you just giving you have a 10 days data, you have a 10 days data, and you ask, and you let us take you have a 10 days data from 1 January to 10th January, okay, and you given me the data only 9 days data 1 January to 9 January, and you just hide your data like 10 January data, and you just ask me, can you use this data and tell me, can you predict me, can you do some prediction for me that what should be the demand for 10th of January. So I'm going to be train my model, and I just go for prediction after training of 10th of January, and let us take I just calculate the demand x amount. So how you can check this is a correct or not? First of all, you are going to be compare with your data, because because you hide one data. So you are going to be compare and you check what are the error. If error is a very much between whatever the predicted and whatever the actual, you are not going to be you are not going to be assume this. But if there is some little deviation and approach to your actual data, then you can take a decision. So the correctness of model going to be decided on the basis of some matrices. That matrices may be mean square error, maybe mean absolute error. So if, although this problem is a regression problem, so if you are aware with the regression problem, how any regression model is going to be selected, the regression model is going to be selected on the basis of uh, error, mean square error, mean absolute error, or R2 square error, or adjustive R2 square error, or AIC BIC parameter. So again, the decision we are going to be calculate mean, error, and all, and then we'll decide how much our prediction is correct. So is it clear?
Yes, sir.
Okay. So as I mentioned, everything did like default, whatever the default function appropriate, I implement. After that, I will create a very dynamic function. You can use it and all. Okay, fine. So let us come into the next part. I'm going to be just handle some seasonality and all, because as of now, whatever the model we created, that model is on the default. So I on the basis of a default parameter already set by Propahat. Okay, so let us take, I'm going to be use some changes. Okay, so changes in model, change in model, and that is basically called parameter tuning and all. Okay, so let us create another model. I just call that particular model. As of now, we created two model PF model 1. Now I'm going to create the 2 model, second model. So as of now, I started with 0 model. Variable just change. So Propahat. Now you can take the number of change point. How many? Initially it was a 25. Let us take, I'm going to take only top 20 change point. Okay, and that is optional, completely optional for you. Now I'm going to be handle the yearly seasonality. So as of now, we is yearly seasonality, because yes, because data having yearly seasonality, na, you already seen. And also going to be handle the weekly seasonality. As of now, we weekly seasonality also put true. Okay, and then let us take a scale. As of now, our change point is going to be calculated for 80% time series data. So I'm going to be change, I'm going to be give some more data. So I'm going to be increase some change point scale. So let us make it as 0.90. Now again, I just do all this thing again, go to the forecast variable, and I call the model, whatever the new model I created. Okay, then I fit, I have a Propahat data format. Okay, I give the prediction, predict value. I'm going to give future data, whatever we created. Okay, you can see here. Now I'm going to be create a figure. Figure is going to be again create with the figure 2, model 2. I plot the forecasted data. I plot with the forecasted data, and again add change point, add change plot, and that is going to be add to the figure, and that figure is going to be just figure. And if you are aware with GCA is nothing, it is going to be put the get current access, and then model 2, and then forecasted data. Okay, now you can see this thing. Now see here, now you can see here I increased the some information. Now there's two things. You can see that this two thing, you have some change point, the basic change point, and with the very 80% of data, now you can see the change point is done, and now they have seasonality. I handle the seasonality, I all this thing. Now let us check a forecasted data frame. If you choose okay, you can did, okay, you can see here. Any problem as of now? So that is a very basic thing. That is the basic thing we done. Now we are going to be create a lot of function. With the help of that function, I'm going to be calculate all this thing manually, because again and again I'm not going to be do same thing like this. I created a 2-3 function. Similarly, I'm going to be create a lot of function, and that particular function we are going to be maintain all this thing. Okay. Okay. Very good visualization I'm going to be do and all. So just have a look. If any question, please tell me. So here I'm going to be calculate the I'm going to be written some going to be write some function. That function is going to be just tell the error, whatever the error you are discussing, how much error is there. Also we are going to be visualize what is the predicted, what is the forecasted, everything. Lot of things we are going to be do. All the things we are going to be predicted and all. Okay. So let us start doing this more program way and very layman simple way. So let us start my first function. Let us I just very top. I'm going to create the top function. So I'm going to create a function, and I'm going to give the name of function is def, and that function is going to be used for forecasting data frame. So it required prop head data frame. What required? It required prop head data format. So whatever the data you are going to be give this function, it should be the prop head data frame. And we already written a function. That function can easily convert any data into the in the form of prop head data frame. Okay. So now let us I just create a function. That function is going to be receive the prop head data format, and I put the prop head data format and save in the this manner. So whatever the data I'm going to be received, the data is going to be saved in that particular format. So again, I'm write a function. That name of a function is, the model name is m. M is going to be called the prop head. Whatever the thing I did, I just try to write here. Please don't confuse. Whatever the function I did in cell wise in single statement, I'm going to put all together. So when you just call to the function, and all the code is going to be done automatically. Okay. So here first of all, I need to put the yearly seasonality. Yeah, I want yearly seasonality. I put the true. Weekly seasonality, yes, I want weekly seasonality. I put the weekly seasonality true. And again, I'm going to be instead of default, I'm going to be check a change point range. The range should be 90% data. Whatever the data you are going to be give, it take a 90% of that. So after this information, I put m.fit. Okay, because I'm need require m.fit, and whatever the prop head data format you given, you just put here. Okay. After that, you need a future data. You required future data, and future data you can create with the this make future data frame. And let us take, I'm going to be assign the it may be also dynamic. You can also create the dynamic this, but I'm going to be just as of now I'm going to be put it as static frequency. I just take a daily basis. Even you can take a yearly basis also. Include, and let us take, I'm going to be historical data in taking care in that particular part. And after that, I'm going to be create a forecast. For your purpose, you say the syntax is very difficult to remember. For that purpose, everything is very clear. You need to remember all this thing. Predict. First, I create a data frame. After creating the data frame, I call my model. After calling my model, I fit my model, and then I generate my future data, and then after future data I start predicting. Okay, so m.predict, and for that purpose I also create the future data and put this future data to here. And again, future data is done, then I'm going to be call forecast maybe a spelling mistake, don't worry, forecast data frame equal to what is exactly forecast data frame. You just copy this term, already written this term, we already written this one. Okay, so I'm just call this one, copy this one and paste here. Okay, so let us take here forecast, and let us take here forecast for okay. So now you can see here, and then I'm going to be return this forecasted data. Now why I did all this thing, try to understand. I created one function, the name of function is simply forecasting data frame. Let us call this forecasting data frame. I call this forecasting data frame here. Okay, and what is the function? Whatever the forecasted data frame you have, we have this PropAhead data frame, we have this. That is our function, PropAhead data format. So I'm going to be give the PropAhead data format to here, and you can see, you can find all this information easily. What is the problem? Period is not defined. No worry, maybe I have misspelled something. Yeah, period you need to define now. How many period do you want? I forget to give. That should be the 5. Sorry. That should be 5. So again, I just call this function, and you can see this. Oh, true is not defined. Oh, I wrongly spelled something. Don't worry. Where is a misspell? Yearly seasonality. This one. Spelling is, it's a typo error. Don't worry. Okay. Again I call. So again this call I function. Now you can see. Now you can see that function return this one. So I'm not going to. So I'm not going to repeat again and again everything. That's why I put all the things in the function format, and that function only required. A PropAhead data frame. And now this function is a generic function. You can give to anyone and they can use this function. Okay. Now I've just create another function. That is the function is going to be. Let us tell I make its function is a. Let us make its function is a forecasting. PropAhead forecasting purpose. PropAhead forecasting function. Okay, so I just taken this, and again similarly we also require the visualization. So I'm going to be also create a function for PropAhead plotting. So let us take another function. At the end I will tell very clearly how simply we can use, and I will also tell how you can use it in your code, like a generic function PropAhead plotting with any data. I'm going to be utilize it. You need to just change the data, and then you need to change the parameter, and you can see the output. Okay, so now I'm going to be plot. So again I'm going to create a function, a def, and I call it PropAhead forecast plot. Again it required same PropAhead data. You require the PropAhead data frame. Just copy this thing again and again for uniformity purpose. I just copy this one here, and again now you need to the same like this. I again am equal to, you need to define the function. You can call this function, you can call this return data frame here, and you can plot. It is also possible, like in but I'll try to write for your purpose that you can remember. So I just copy again this thing here. I copy again, sorry, I copy again this thing here. Okay, so let us write down. Don't worry, I'm not going to be believe on copy paste. Maybe it's mislead us. Okay, now so m equal to, I just define m equal to a variable propahet. I define my function propahet, and then after propahet, I'm going to be just again seasonality. I put the true again. Again weekly seasonality. I can also put the true again. You just check a change point range 90%. Okay, that is the first thing. And again I fit my model m dot fit, and here I'm going to be give the propahet data format. Here I'm going to be give the propahet data format. Okay, and after that, and okay, after that, what we need to do, we need to again generate a future data. Future data is going to be generated by m dot make future data frame, and again we take a periods, and let us take for 5, and you can take that, it's also dynamic. You can create a variable here and you pass the variable here. It's completely up to you. So as of now I'm not much concerned about this. Frequency 5 and historical information I'm going to be include true. But if you want to also update all these things, let us take how you can do this. Okay, so let us take here, I'm going to be do here period, I put the period, and by default I'm going to be the 5, and that period is going to be put here. So if you're not going to be assigned anything, it's by default 5 again, and you just take a m period, because for variableness, and then again I just copy the frequency, and frequency, okay, and frequency, let us take m frequency, and it should be day format. It should be day format, so you can put the m frequency here simply. Okay, so you can do also for same thing. It's so if you are not going to be assigned any period, so by default it's 5 and frequency is day, and if you are assigned, it is depend upon your assignment. Okay, don't worry. So I just did it, and then again forecast equal to m dot predict, and I just take whatever the future data you generated. I just copy this and put here. Okay, and then simply I just return, I just return m dot plot. Okay, what plot? Just call to forecast. So again there is a plotting in function is created. Now I'm going to be call this function. I'm going to be call propahet plot. I'm going to be called propahet plot, and I'm going to be just pass a propahet data frame. Just pass propahet data frame here. Now you can see the automatically the graph is going to be generated. Forecasted graph is going to be plotted. So I'm not going to be call the same function again and again. I think this is a clear. This is a clear. Why 2 times? Because I need to return something. Let us check why it's going to be happen. Go to the function, and I'm not returning anything. Let us take this function simply, and again I run it. Let us rerun all, reset and rerun all. So I think you people try to understand why every time we focus on the function, because I try to make everything is a very dynamic, so say so we can utilize all predefined whatever the code we written, whatever code whatever exercise I'm doing here, you can also use this as a package, and after at the end I will show how you can use this as a package. Don't worry. No. So now I think, is it clear for you? Because I returned twice, that's why it's doing that. So you can see this. This is a function I created. Now just move the basic and most important part for how we can create the error, how we can find the error, all this error. So I'm going to be also create a one function. That function is going to be give the error. So all this function I have PropHat forecasting function, PropHat plotting function. Then I'm going to be add another function. That function is a basically call it error. How we can find our model is how much error the model is going to be give. So for that purpose, I just again call this error function. Okay, so how we can calculate the error? Sorry. Simply you can read the form. Okay, so simply I just come here and I just call add another cell. I put def and I call this PropHat sorry, that is a PropHat. I just spell a, don't worry. You just use a small a. That is function. It could be anything. It's my name, don't worry. Okay, I just use the forecast and I just put the error. It could be anything. It's complete change. Now again I just take a same PropHat data format I put here because I need the same data again and again. And again I copy the same thing. I created this thing. You can utilize the previous value also, you can utilize, but I repeat that you people understand how code is, how syntax is. Otherwise I can return the value from function from first function and utilize in that particular function. That is also fine. Then again I put mfit. Again I put mfit. After mfit I generate the future data. Okay, so future data, I'm going to be generate the future data. Okay, so future data is generated, and after future data I just take forecasting is going to be happen. Let us take, I take a forecast. It is done. So that same thing I repeat again and again, so you can return the value and you can utilize it, but don't worry, I'm going to be use it. Okay, so I just forecast true, and then that is a forecast. Now this forecast having all this information, now I'm going to be create some error. How we can create? If you see this line, if you see here this forecasted data here, if you see here, this forecasted have a lot of information, trend, I think yearly and all. So by using this information I'm going to be calculate the error. So try to understand how I'm going to be create the error. As of now, if you just forecast that here, so you can say dot head, I'm going to be show the first row so you people understand. What I try to do, I'm just going to be create the some value. I'm going to be create some error always going to be calculated between y hat. Error is going to be always calculated within, I already given the example, y hat and y. What is exactly y? I haven't take a y, but yeah, that is a y because the data already contain the y. Okay, so I'm going to be calculate the error between predicted value and real value, and that is basically called the mean square error and all. So let us do how we can calculate this. So for calculating this, I just call this root mean square error. Okay, and that root mean square error I just called np dot square root. Np is already created, we just imported np dot square root. I'm going to be calculate np dot mean, np dot mean, and for calculating the np dot mean I'm going to be just calculate forecast, the variable, whatever the forecast variable, and it contain loc. Loc is a way to access the row or column by its name with location. So I want to access all the information corresponding yhat. So I extract all the information from this, and after that minus Propahet data frame, what you are going to be give, that data frame having y, because actual value that having y. Okay, that is done, and I'm going to be multiply square root, that is twice. So that is going to be give the mean. Okay, that is going to be give the RMS. And how we can find the mean? Mean we can find mean equal to, simply we can find Propahet data frame dot mean. Propahet data frame, sorry, we need to the y, and then y is actual value given in the data, mean. Similarly, you can find max, what is the maximum value. Similarly, you can find same thing, and we just copy and paste here, and you can find here max value. Similarly, you can find all. So what is the maximum trend, what is the maximum value of in the data set, what is the error? So you can compare this, all this thing. Let us check what is the minimum value. So you can find same thing, and you can just paste it and find the mean. And if you want to create a data frame, you can create a dictionary and all. You can find a df equal to pd dot data frame, and what is going to be happen, let us call uh, uh, um, the first thing. What is the first thing? First thing, RMS. I put the RMS value is RMSE. Again I put here mean is, I put the mean, and again I put max. I put the max value is max, whatever I calculated. I just formatize, and then min value, then I put the min value. Okay, that is the information, and return df. Okay, so now I call this function, because Propahet data format already defined. Okay, so I just call this function, and let's check what is happening with the error. Propahet data frame is not defined. Okay, maybe what is the value? Let us take this one, and then is this one. Okay, so now you can see here, after calculating all this thing, warning is why, because there is a one mistake, df dot data frame. What is mistaken? If using all scale value, you must have passed the index. Fine. So what I did, in my for df, come here, panda data frame, that is the RMS, this. Let's not return a dictionary. Then I'm going to put all this. Okay, let us take df like that. So I just put here, and you can put like that. Fine. You can find RMS is this, mean is this, max is this, and minimum is this. That is a complete. So root mean square error is a very less, 7.95. So that model is a comparatively good, because the maximum value is complete data set is a 50n, minimum value is 28, okay, mean value is a 28, and mean is a 28. So minimum is 28.17. So that is mean also. their measurement must be different, but I may be wrong, call anything wrongly. Then mean. Okay, I put here mean, so here should be mean, M-I-N. Okay, so that is the thing. So if you want to create a proper data frame, so you can just also create like that. Okay, so this is the thing. You can convert into data frame as a list format and all. Okay, so I think this is clear to you that here the model having uh, only error for this particular forecasting, that all the things. So I think that at 7.9 thing, minimum value is 6, maximum value is 28, and your error is 7.95. So whatever the prediction you are going to be perform, maybe it's root mean square error plus minus 7.95. So that is error. So that is the assumption. Now let us plot all this thing. Let us plot all this thing. Means I'm going to be plot all this thing, like what is a trend in the data, what is a upper limit of the data, what is a lower limit of the data. I'm going to be plot so you can take a decision. So let us plot another function. Let us plot another function, and that function I'm going to be call. Let us take def, and let us take data. I'm going to visualize all the forecasting. Prop het and forecast. Let us take visualization, VISUAL. Okay, so I put the Prophet data frame which is here. Try to understand, then I'm going to summarize everything, then you people understand how you can utilize it. That is a lot of things mixed together. Then no, don't worry, I will structurize all the things. So M equal to, again I'm going to be copy this same thing till a forecast data, and you can utilize this. I copy paste, that is not good way, but I have to create the function. You can utilize it, but for your purpose, for simply I just use it. So I just take a model you take a, if you want to remove the daily like a daily seasonality, you can also handle daily one. Okay, because that particular model you can handle the weekly seasonality, yearly seasonality and daily seasonality. Okay, so I do all this thing. I feed the model with the prepared data, future data I predicted, forecasted. Now I'm going to be plot. So for plotting purpose, I am going to be add a plot offline. Py is already there, so I'm going to plot everything is offline. So I'm going to be called py dot iplot. Okay, interactive plot I'm going to be do, and then I just put a function, and then I'm going to be put a multiple graph at the same graph. Try to understand, you will understand. So how I can do, I have already go object, so I'm going to go here, go dot figure. First I'm going to be plot go dot scatter plot. Okay, and then I'm going to be plot x equal to whatever the Prophet data you have, whatever given the Prophet data we have. I just call here what I'm going to be find, because this data having ds, don't worry. And then similarly y is going to be happen, and that y having a y. Take it, and now I going to put it name. The name, this graph is basically known as an actual event, actual data, actual sales, we can say that. Okay, after that I'm going to be, that is a one graph is going to be draw. Similarly I'm going to be draw another thing, go dot plot, scatter plot basically. And again I just here I just talk x, and I have already forecast variable. I just call this forecast and put here, and from the forecast I'm going to be create a ds. Okay, and y I'm going to be, it is a basically nothing, it is a forecast. And you already aware in the forecast data frame there will be predicted value is represented by y hat, if you know. And I'm just going to be call its name of this graph should be predicted cell, predicted cells. Again, put the comma. Again, I'm going to be plot. Again, I'm going to be plot dot go dot scatter. Okay, go dot scatter. Now I again going to be again forecast real time, because y-axis always ds means data set. Okay, date set, sorry. Then again I already put all this thing, then I put the y equal to forecast. Then here I'm going to be put here y hat upper, that you can extract from this information. I already written here y dot upper and then lower. Let us take y dot upper. I just consider here from that place y now, and that that I going to be call. I'm just putting this this as name equal to upper prediction. We can say that upper prediction. Similarly, I just copy this, and everything will be same. Everything will be same. I'm going to be just call this, and I put y here lower prediction, lower prediction, and y instead of y upper we can give lower. So multiple, I'm plotting a multiple graph simultaneously. Similarly, I'm also interested to plot trend. What is exactly trend? Okay, I just do it scatter plot, and I just ds, and here I'm going to put trend, and here that is we can call here trend. Okay, so that is thing, that is I just put here, I just call this function, and let us see what is going to be happen. I call this my prophet function bottom, and put here and put this. Let us see what is going to be happen. Maybe definitely I'll writing the code. Maybe there is a, so here ds y forget upper prediction, there is a one error in that particular line. Prediction error is basically d, I put in the dx, it should be ds. I put the xx, sorry, that should be x, that should be the x, that should be the x. Okay, I run this thing, and I do the same run here, and you can see here. You can wait and see the result. Now you can see here proper result. You can see here that is a trend, that is a trend, and that is the actual value. These are the over, that is the actual value. These are the what is this? These are the basically very high out these, and these are the lower upper prediction, that is our upper prediction, and these are the lower prediction. So you can say that our data is a very good, means our prediction is very fine, and that is basically a predicted sale, that is a basically predicted sale, whatever we predicted, and this is the actual. So we can see that our prediction is not very good, but yes, somehow it's overlapping. The upper prediction is good, lower prediction is also good. So we can decide upper prediction is good or lower prediction good. We can say that we can take a decision. We can say that at that particular day, at that particular July, actual sale was 50 and predicted sale was 49. Let us try to understand. Actual sale was 50 and predicted was 49, upper prediction, and maybe at that particular, so we can take a decision, and we can take a decision that that is a upper limit, that is a lower limit, and that is a prediction. So we keep, okay, so a salesman going to be take a, so if minimum requirement is going to be happen, that is a minimum, that is a maximum, and that was a trend. So trend was this, we can say that that is an increasing trend, that is not a constant, that is an increasing trend we can see here. So the graph is not quite look quite good. So let us, I'll just do some other thing. I'm going to be add in upper and lower, I'm going to be fill some with some more information. Let us take fill, and I'm going to be take a variable, a method. Okay, and let us take, I also put mode. You can also put the marker, a lot of things you can done, but let me say if any changes happening. So I just copy again this thing, and I also paste here. Okay, so let us run again, and let us say if any changes in a graph. Now I'm going to be just create everything as a function, and then okay, now you can see here. Yeah, now that look better. Let look better. You can find some more thing. Okay, so that is a overall thing, that is the overall prediction we can make. And all, now let us create everything. I'm going to be create a function. So I'm just going to be create a notebook, and then for simplicity purpose I'm just going to be call a function, my prop head function. Let us call prop head function. Okay, okay, so that is a function. Let us call, I just call first name function, and then prop head. Okay, now I'm going to be call all the function one by one. Try to understand why. I just copy and paste whole this thing here. Okay, and I'm going to be call the first function. I'm going to be call the first function is basically, I'll just copy this all this thing one by one. I just copy this function. Okay, again copy second function. I'm going to be copy plotting function. I'm going to be copy. Okay, what should be the sequence? I'm going to be tell how you can, maybe as of now I did a lot of things. So what should be the sequence? I just copy this here, and again I just copy this one to here. Okay, and again no, I'm not going to be do with anything here. I'm going to be copy all the function. I'm going to be club together. There is a function, and let us take plotting function. I just plotting function here, and again. I think nothing, no function here. Everything is fine. So now I'm going to be, I have a function. The name of function is these function. These function. Okay, the name of function is all these function. Okay, now I'm going to be call let us take, I'm going to be use this all these functions separately. So what I did, I create one file again. I'm just create again one file again, and just call my prediction, my sales prediction. For that purpose I require some library. Let us for my sequence, my like easiness, I just import, but that's not necessary. For that purpose I'm going to be read my data, try to understand, and I'm also going to be import I and B. Okay, so I have to install one library. The name of library is called import I and B. So let us going to be run this import I and B. So how we can install the import I and B? I'm just going to be copy this function here, copy this function here, go to the my Anaconda prompt, because you have to install, and I just install this thing. Let us wait. How we can import R function? Okay, so let us take all this thing. Now it is imported, fine. Now I'm going to be import this function, import No, not here. In which, where you want to use this function, import IPNB. You can see now. Now that is a way. That is a user defined function you already use. Now this function propahet is my function. Now I have to import this function into the my notebook. So I copy the name of function, and then let us take, I import this function, and I'm going to import this function simply. So if you see this, now I'm able to import this function. That import function is designed by us. Maybe I just written some wrong name function, and now I just copy again this one and just again rerun this function. No, it's not required basically, but yeah, for precautionally. Okay, so the function is still running. Let us say, so here, like if you see here, propahet is a general package. I also create my own package, and now you are able to import. Now let us read data. Let us take, first of all, we require the data equal to we already written some code for importing the data. So let us copy and paste here. I just read this. Now that is the only thing we need to know. I just read this data. Now you can see here, our data is imported. Now fine. And now if you see this data, that is the data. First one, if you data dot it, now you can see this information. Now you can able to read the data. There is no big deal here. Now important thing is that I'm going to be just extract the information. I want to extract the information for store 1 and item 1. So how you can extract it? Let us take store item data. How you can use? You need to just call function propahet, that is a R function. And what is the method name? Method name is, we have a lot of method we already defined. What is the method in here? If you see here the method, how we can import the method? The method is data cell item store. Okay, that is the name of function. So I just come here and just copy this, and we need to pass what? We need to pass the data. Try to understand how useful data. And what is the first argument? First argument, as we aware, the first argument is item and second argument is store. So I want the all item corresponding store 3. You can see here. So now with the single line of code, we can extract that information. So people don't know what you did. People just see the result. Okay. So what I did, I just import the function and I create the function. After creating the function, I did this. Similarly, if you want to plot this thing, how you can plot? Propahet. What is the name of the function of propahet? We already aware, for plotting the store data, that is a function. Okay, what we required? It required the data. And what data? We require the data. I want the store 2 and 3. Are you getting? So similarly, if you want to plot with some different thing, let us take 3 and 2. So that is completely up to you. That is exactly known as a programming. Okay, so I think this is clear. Now again, one by one, I'm going to run again a program. So what is the first step? First step, you need to convert your cell information. You need to convert into the cell information in the propahet data, like that. How we can convert the propahet data? For converting the propahet data, we already have function. What is the function? The name of function is what is the name of function? I think I haven't copy paste. No, I haven't copy paste. So let us copy and paste that function which convert your data function into other format. Yeah, that the function I haven't copied. Okay, so this is another function. Okay, and again I rerun all this thing, reset and rerun. Again I come here in my cell prediction. Okay, I just comment this my purpose. Again, I just rerun all because I changed it in my function. So we again run required to run. Now I need to the Propahead data format. Like if you see here, we did now Propahead data format like this. So we can copy this and you can come here, and that is a Propahead data format. And now we just put the this function Propahead because this is in this particular format, and you already discussed about which function that is the actually store item data, and we're talking about the store 2 store 3 item 3 item 2. So you can see here, no attribute Propahead data uh, function. Maybe it is not rerun again. Let us take rerun all because that maybe it's not imported. Let us see. Yeah, it's yeah maybe. So let us start kernel because the function is not imported. So I just going to be restart the restart the kernel again. And again I kernel, I just restart again. That is a matter of linking. Maybe that notebook it not linked with. Okay. Now I just function Propahead. I just call this function Propahead is not defined. Why it's not defined? Because function Propahead name function Propahead is not defined. Because that is defined. Here is running. No. Function Propahead. Fine, that is a function Propahead. Yeah, now it's fine. You can see here that everything is going to be automatically converted to that format which actually we required. Now we can start working because already did a lot of program, lot of function. Let us do one by one whatever you want to run, how you can run. So if you want to directly simply want to the like forecasting data frame, to just copy this already the function, just copy this, put the function Propahead and just run. So single line of code, you can check the information. And similarly, if you want to find the error, because we already calculated the error, okay, if you want to run this, you can this thing, you can plot this thing, you can plot. You need to just put function Propahead and all. So you can give this model to people and people can use according to their requirement. If they want, if they are working with the store 2 and item 3, so they can utilize the same thing for store 2 store 3 and all. So anyone can use according to their own purpose. So that is my purpose for creating that uniformity. Okay, so I just give the again function Propahead. Okay, and then last function which we created this one. So now I'm going to be delete this one because that is a useless for me. Now there is no use. Now I have a okay, let us copy this function. So what is the problem? Name PropaHead data format is not defined. So come into that function. What is the name of function? The error function. Go to the error function. Check what is the happen. PropaHead data format is there. PropaHead data format is PropaHead data format. PropaHead. No, not this error. PropaHead data format is there. PropaHead data format. Fine. Forecast error. PropaHead data format. Let us copy everywhere that PropaHead data format. 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 That was the problem. So I just again rerun all. Now it's done. Again I restart my kernel. Restart my kernel. And again restart and clear output. And again restart and rerun. So now we need to focus this, how utilize that, how critical and how that unstructured program look very structured for us now. So you need to know the step by step and just you run it. So that is only matter of people who belong to the which store and in which prediction, which for which item they want to predict. Still we can more structureize this. Now you can see. Function PropaHead.ml PropaHead, why it is giving error? If that is a fine, then why it is give the error? No problem. It is not mandatory, but there is something where I misses maybe some place where I miss. Let us copy this whole thing. And where is PropaHead error? I just come here and check what is exactly error here. I just copy this here and I directly run this function. Let us check what is the error. Yeah, there is a no problem. What it exactly mean? That function is not able to, here is a no problem. So let us copy this again, paste here this again and again, kernel, and let us take rest. Maybe sometime the uh, function is not going to be link with the notebook. Fine. So again, let me restart and rerun all. Okay. Okay. It done. It done. Everything is fine as of now. Good. Now I just call as a function. I remove, delete this one. Let us, once it's run, yeah, function is created. Let us now, I'm going to delete this one and call by function. Okay, again rerun all. Let us check what is happening. It should be run. So that is agenda of whole the session. I try to just start from very basic uh, programming and try to cover how we can create the function, how you can create a dynamic function, how you can utilize this. And now just share this function to anyone, or you can deploy this function to your cloud and just create a one UI. From that particular UI, people can only select the store name and store name and store item required, and they can predict it. Are you getting? So simply someone simply, that is the same thing. That is only notebook, and the function, all the function is here. We created, put all these things together. It look very beautiful. And then if someone asks, no, I'm much interested. I want to, here you need to only give the item and store. What you need to give? Item and store. Because okay, how you can people use it, item and store. And after doing all this thing, you can create a front end by using HTML, whatever the front end technology you people are aware. And then just create a one very good, a very basic UI from where people drag and drop, drag, or they can select from drag and drop list, or they can enter something in the edit box, text box. So it's completely up to you. Create a mobile application, create a web application, and just ask from the user, do you know, just send me the data, please provide the data to me. And after providing the data, can you tell me, I want the prediction of the third item, and the store is 8. Just rerun all, just hit the function, and you can find all this thing. So I just made one change, everything is done. That is a use of that in that particular may. I mean, how much time is taken? Within 2 hour, within 2 to 3 hour, I just summarize all this thing. So I start from scratch coding, from very layman style, and then club together, and then after I use the function. So okay, so that is the thing. That is, you can see everything. Okay, so fine. I think is it fine for you? And I just try to cover all this thing. I will deploy this code over the GitHub repository. Just go and check on my GitHub repository. I will going to be put the code in on my GitHub repository, and then the video maybe I'm going to be upload. Okay, so fine. So now if